As the electron orbits about the nucleus, or as it's in an orbital about the nucleus, this electron itself is going like this, and then the electron itself will rotate in a direction. It can be rotating in this direction or this direction as he rotates about the nucleus. This electron moves at such a high velocity that it sweeps almost a shell about the nucleus, a cloud. This is why we use the velocity for electromagnetic radiation, which we represent with the letter C, which is associated with the speed of light. Radio waves travel at the speed of light. Microwaves travel at the speed of light. With this electron moving about the nucleus at such a high velocity, and then the electron also has its own rotation, all this movement is going to cause some wild shapes. So it doesn't always make a perfect sphere. To help understand the structure of atoms, chemists use quantum numbers. The letter N represents our principal quantum number. Our principal quantum number, which can be given a numerical value, it describes the size of our electron cloud. I'm using this word orbital, not orbit. Orbital describes the probability of locating an electron. The Pauli exclusion principle states that no species can have all the same quantum numbers. They consider that the electron is moving so incredibly fast that at no particular time in space can you locate it. So that's why it's an orbital. It's probably in this area, probably not. And considering the ground state, when the electron is closest to the nucleus, you have a higher probability of locating the electron more close to the nucleus. Our next quantum number is lowercase l, angular momentum, and that describes the shape of the orbital. It's called a quantum number, but angular momentum is, they're assigned letters to describe the shape. Some shapes of our electron clouds, our orbitals, are assigned the letter S, P, D, and F. And I will explain these shapes in just a bit. Our magnetic quantum number describes the orientation of the orbital. We perceive objects in 3 dimensions. Our orbital can be along the x-axis, y-axis, or z-axis. I will illustrate. Our next quantum number is the magnetic spin of the electron, represented with a positive symbol or a negative symbol. Maybe it'll be a positive 1/2 or negative 1/2, or even an up arrow or a down arrow. And this describes, is the electron spinning in this direction or that direction? Let's describe in more depth angular momentum, represented with the lowercase l. Our angular momentum describes the shape that the electron cloud will sweep about the nucleus. Our first shape is represented with the letter S. The letter S is our simple spherical cloud. And I would like to draw this on a graph. So once again, we perceive objects in 3 dimensions. 1, 2, and the 3rd dimension is going towards you and away from you. So that's X, Y, and Z axis. Our next shape, represented with the letter P, I illustrated 3 different orientations. If you remember our quantum number, magnetic quantum number, it describes the orientation. Our P shape can be oriented along the x-axis, y-axis, or the z-axis. you can see how the electrons are shared. They're either donated or they're accepted. The more electrons an atom will have, you will have all these different shapes layered on top of each other. Our first two electron clouds will have the S shape and then the P shape. And then the D shape becomes a lot more complicated. Our D shape will have electrons arranged in a much more complicated shape, and then our F electron clouds are even more complex. Another trend on the periodic table of elements, because remember our Russian scientist Dmitry Mendeleev organized this table in a very specific way, and everything is placed strategically. Our electron cloud shape in these two columns will have the S shape, and then we have our P shape. Our transitional elements will have the D shape, and our synthetics will have the F shape.